There are two different kind of people in this world.
Okay.
Even 3 or 4.
Okay, welcome everyone to AI Every Day. This is week 3, and we are excited to have everyone joining online and physically. Okay, people online, say hi, how are we doing? I can see we already have quite a number of us on the call. And for everyone joining physically, I say welcome to week 3 of AI Every Day. That's been 3 amazing weeks. I saw a lot of comments on the last assessment shared in the classroom, so I'll try to answer that today as well. So welcome everyone. Sorry for the short delay in starting. So just a minute, we're going to be starting right away. If you have, okay, you're welcome. I see some of us raising our hands already. So as always, if you have any questions, just go ahead and drop it on the chat, and my colleagues are going to answer. Okay? All right. So we'll be starting in a minute.
Oh, that's not
So today is a very special day. We're continuing the technical sessions of AI Every Day. We've had awesome sessions on Google Classroom. Wow, from Unsuka, you're welcome. And we've had quite amazing feedback from everyone. We've been able to get working with Python, right? I'm asking us, right? Yes, sir. How many of us tried out some of the projects? Even if just one? Nice, wonderful, that's nice. Nice. Any questions or concerns before I even get started today? I just want to take a few, if any. All right, so okay, I see something in the chat. Oh, hi Adewale, greetings from Lagos too. All right, so let's get into it. Today is a very special day. We'd like to say Happy International Women's Day to all our women in the house. Can we celebrate the amazing female coders we have? Our ladies of AI, and we are so excited to have you all joining. There was something remarkable happened last week. Looking at the records, and we're sharing how that it was actually funny because we had more female participants last week than previous weeks, and I'm hoping that's going to continue because it's open to everyone. Come on, let's get everyone that needs this in there. So happy to celebrate you. Thank you for all the amazing things you do, and keep up the learning. So as always, you know our classrooms, right? COVID-19 preventive measures, please masks on in the mask wearing areas as indicated, please, as much as possible. I'm glad that we have not had any issues of well, I don't want to of disrespect during this session, and I'm trusting that that is going to continue. So as much as possible, we have not had to kick anyone out of this program, and that's amazing. Everyone, I think we should all maybe celebrate ourselves. Well done, everyone. Well done. In case of a fire, the fire exits are on the left and the right. And as always, attendance in the live sessions is compulsory. Please and please ensure you fill the attendance as we shared. How many of us have, maybe you missed an attendance or you did not fill one? Let me see your hand. Oh, lovely, nice. That means I was going to say something, so I might not have to say that's if nobody here has missed, and people online, let me see. You missed an attendance. Okay. All right. Don't worry, we'll see how we can sort that. As long as you attended, okay? So we know how you're participating. You're joining the live sessions. You're on Google Classroom, okay? You're completing content on Google Classroom in the recommended time, okay? You're completing the assessments, and you are talking to other people in the program. So I want to ask, the Python video is shared for week 1 to week 2, because this is week 3 now. Someone's already nothing like, I know you're agreeing with this. So how many of us have been able to watch? I've watched one video. If you are on for people on the chat, right, you will get the attendance link, okay? For people on the chat, just say yes. Just say, or no, type one video. If you have watched one video, people physical, let me see your hand. One video, at least one video, let me see your hand. On the chat, at least one video, type one video. Wow, someone says all. I mean, wow, we have people that have watched all the videos. You are amazing. You watched 3, yes. 2 videos, 3 videos. Wow, 4 videos. 5 videos. All the videos. Wow. Can we have some fire emoji in this chat? Please clap for yourselves. The people, our online audience are totally amazing. Wow, wow, wow. Please, we have multiple people who have actually, followed more than, in fact, completed everything. Wow. So, well done, everyone. And I think that's a big milestone for all of us, that we have enough people that have actually checked that out. So well done, everyone, and kudos on that. So you know what to do on Google Classroom to access the classwork. I want to believe some people are still joining, so we cannot overstate this. Please make sure you access all the content. And of course, for people physical here as well, everyone here must have signed the attendance already. But if you have not, please use the QR code now or the link, and please sign the attendance. The link is being sent to the chat now, so you can access that on the chat if you are following online on YouTube and on Zoom. Okay, great. So please confirm the link has been sent to the chat. Great. So please fill the attendance and let us get started on today's session. As always, you know the requirement for the technical sessions. It's either you're on Google Colab or you are on Jupyter Notebook, right? Colab people, let me see your hand. Team Colab, Team Jupyter. Wait, how is the class segregated like this? How come Colab people are? Colab, let me see your hand. What kind of data pre-processing have you people done already? You've not gotten there. You people have already clustered yourself. This is a clustering algorithm. You've clustered Colab to this side and Jupyter to this side. That's amazing. Now, that is random, right? It's totally random, but it's so definite. That's amazing. Okay, so as always, we know the criteria. If you are running this program and you want to get the part of completion, you have to complete all the assessments with at least an average of 80%. You have to at least 3 out of the 4 live sessions you must attend. And if you do all this, you will get the verifiable badge of completion. Okay? All right. So let's get into it. Today we'll be working with a data set. So if you are here, and because everybody will be following live, you can, this link will be shared in the chat as well for people following online. You can get access to the data set. Just get this link now. You can use your Google Lens with your phones, copy it, or type it out now in your browsers, or it's already been shared to the, excuse me, Google Classroom. So you can just download it there. Okay? So you can just download it there. If you're on the Google Classroom, which you should be, you can download it there. All right, thank you very much. All right, so have we gotten the link? People online, you can just go to Google Classroom from your phone or your PC as well, because you need this data set on your laptop. So just move the data set to the root folder of your Jupyter Notebook where your Jupyter Notebooks are stored, so that you can easily access it when we get to it. Okay? Okay. Let me see. I hope we are trying. Okay, I'm still trying to download the data. All right. So it's a very small data set. It won't take long at all. All right. So you can just save this somewhere and we'll move on. Okay. So let's get into today's work. Okay, so today is Introduction to Artificial Intelligence and Machine Learning, and we will be covering first simple concept of machine learning, and then we will move and also take the lab session and implement everything we are talking about in Python. Okay, so it is, as always, and I like to just reiterate so as to assuage any fears and let everyone know it's a beginner class. Okay, it's a beginner's class. You will get explanations. We're going to explain everything, and we'll make sure it's as basic as possible so that everybody can follow along. Okay, so for the experienced folks, you have 1 or 2 things to learn, and for the beginners, you have everything to learn. Okay, are we on the same page? How many of us have gotten the data set downloaded? Nice. Nice. People following online, how many of us have gotten the data set downloaded? Okay, cool. Let's get into it. So have no fear. Even if you do not have the data set downloaded, please note that you can still follow. We are not going to use the data set until about the end of the class. Okay? So please don't be distracted, and we can all just follow. So, I'm going to show the link for the data set again. But if anybody needs the link to the data set, for those people, let me just, okay, I'll just share this again then. Let me go back here. Okay, so even for people following online, please, the dataset link is up again. Please use that. Okay. All right, so please find it on the screen. You need a link. Yeah, it's on the screen. I'm seeing someone asking for the link to the Google Classroom. So as always, just all you have to do is register and you get the link for the Google Classroom. All right, so please, if you can't get the link, just store it because someone can share it with you. All right. Okay, great. Someone has even shared it for the team on the chat. Nice. All right, let's get into it. So today we're going to be covering the concept of machine learning. It's going to be a technical introduction to machine learning. We've been introduced to artificial intelligence already. So basically, we're going to look at some applications as a use cases for some simple algorithms. I'm going to also differentiate between some of these concepts and then the types of machine learning. So basically, it's an introduction to the algorithms. We're going to look at how they work. I'm going to look at, in particular, linear regression. It's about the simplest machine learning algorithm, and it's super intuitive, simple, and fun to actually learn. All right, so are we ready? Can we go on? Awesome. So what is machine learning? We have talked about this previously, but again, and I like this definition because it's more suited towards the technical work we'll be doing today. It's the ability of computers to identify patterns of past occurrences. So there is a data of how many, for example, how many people, what times people come to this class. I am sure that if we actually took the times that everyone stepped into this class for people joining physically and even online, because online, I mean, I have seen that there's actually a trend. And we can tell that I know the time that the number of participants in the class will likely climb out, that will be the highest. Okay, there is a certain time. Over time, there's that data. So we can take this data and we can find a pattern. Usually, for small data sets, we can see this pattern with you can just look at the pattern, simple statistics, and you can see the patterns in the data. You can look at maybe your routine of how you get, or the days you go to work or go to school. And you can look at that and say, oh, wow, every day I took a bike, I got to school early. Every day I took a bus, I got to school late. There can be a direct correlation actually between those. And you can say, that means every time I take a bike, I'm more likely to get to school earlier, right? And I'm speaking truth because I know that every time I take a bike to work, I'm going to get to work early because the bike can easily navigate through the traffic, you know? Am I correct? Exactly. So there's that established pattern. But for larger data sets, with maybe 10, 15 variables and millions of rows, you might not be able to easily identify those patterns. And that's where these amazing algorithms of machine learning come in. They are able to identify the patterns in these data sets and then learn these patterns. Okay, like I don't want to use the word memorize, but actually that's the term. They don't memorize the data set. That is not the goal. The goal is to memorize the patterns in the data set, how each feature relates to another, and then they use this to do what? Make predictions on similar instances. So when there is now another question of, oh, am I going to get to school early today or not? It can use the pattern it has learned to now make a prediction that if you do like this, you most likely get to school early. It's the same thing with probably you have for the last 10 years, maybe you have the way you've been creating your spending and you've been maybe storing that in some kind of a data set that is structured. If you got some amount of money, most likely we can find a pattern to your spending and we say that by weekend, you might likely go broke because you have a very dangerous spending patterns towards weekends. So different patterns can be deciphered from data, and machine learning algorithms are able to store these patterns, learn these patterns from data sets, and then use them to make predictions on entirely new instances of the data. Is that clear? Totally clear? Does anyone want to explain it in their own words? Not, and you see, I like that. I'm going to remove this from the screen so that nobody is seeing this and reading it out to us. Does anyone want to take a shot at it? Now, machine learning is simply a machine, a computer, learning the pattern in some data set, in some occurrence, in some event, in some past, right? And then using the learned pattern to what? Make prediction on the future. It's the same thing we do. Some days you just know that there'll be traffic today. You wake up and you look at the time, you know, I'm going to be late to work. But you still have 1 hour. How do you know you'll be late? You already know that on Tuesdays, there's heavy traffic around this side. You just know because of what? A lot of experience. But now machines are able to do it more accurately and in fact see more patterns than we can even see. So who wants to take a shot at it? Anyone? People online, please, I'd like to see your thoughts, your summaries. Anyone? Nobody. Okay, someone wants to go. Okay. Go ahead. Yes. Beautiful. She said, using understudied past events to make predictions on the future. To join the Google Classroom, please register and you'll get the link to join the Google Classroom. Okay, so let's go on. Now, as we go on in the class, there are some concepts or some words or some terms you'll be hearing frequently. In fact, today you will hear them a lot, and next class you will be hearing mostly just those concepts. Okay, one of such is data. And when we say data, we don't mean MTN 2 gig or Glo 5 gig. No. When we say data, we mean any digital representation of events, occurrences, or information. That is, it can be a picture. We can have pictures of cats and pictures of dogs, and we want the computer to be able to recognize if it's a dog or if it's a cat it's looking at. We can have pictures of cars, different kinds of cars, and we want the computer to be able to recognize what kind of car it is. Let me give you a very simple application of that. I mean, if you have passed through maybe estates or restricted areas and you see guards using pens to write car numbers or car makes when the car comes in, and when the car comes out, they'll sign it out. Have you seen that before? I've seen that a lot, and I always wonder, like, this is a beautiful, because it's really simple and it's established AI to be able to read. I mean, the plate numbers are digital coded. AI can easily read that. As a matter of fact, we're going to see something like that in the next class. Handwritten digit recognition and some kind of computer vision, how artificial intelligence and machine learning can learn. It has learned how numbers looks like, and using optical character recognition, it can recognize characters written. So it just maybe point the phone at the car, and it takes the numbers and they can record that simply. So just like that, data, it could be videos, right? It could be a video. Video is also data. Like we shared in the first class, remember, data never sleeps. Where we shared how many millions of videos are being generated per second in the world, how many tweets are going out. It could also be text. So basically, it's any digital, but it has to be digital. I mean, we can't slot in our paper to our computer. Well, we can't. But I mean, today we can just now. It's amazing the things that how easy AI has made life. And for people that use AI products, I remember I wanted a phone number and I couldn't find a pen. I didn't want to memorize it. I just took my phone, and it was handwritten, and all the numbers were correct. Of course, the handwriting was legible, not the funny kind of handwritings, right? So it's amazing, and I want us to begin to look at these applications as things that are here and now and things that we use every day. Okay, let's go on. You'll be hearing a lot about training, and it's not maybe you run 5 laps, do cardio in the morning. When we talk about training is simply the process of teaching the machine learning algorithm to identify the patterns in a particular data set, a collection of data points. So a collection of data points is a data set, right? When I say data set, we mean like all this data, they collect around the same events, the same subject matter, right? And they have been properly structured. It could also still be structured or unstructured. When I talk about structured data sets, we mean data that is usually in tables, right? There's a structure to it. We know that the rows mean this, the columns mean this. And when I talk about unstructured, usually they are higher dimensional. That is things like compare your table to your pictures, to videos, to audio. Okay, those are unstructured. All right, then you talk about features. When you talk about feature, a feature is, you can think of a feature as a column in your data set. If you have a data set that describes the days you got to, the times you got to work or school, the features would be things like, did you take a cab or a bike? That's a feature. Did you wake up early or not? Did you wake up before 8 a.m.? That's a feature. Did you eat that morning? That's a feature. You get that? So the columns are the features. The features are the data points that will be used to train the machine learning algorithm. They are the independent variables that the dependent variable will most likely be trained on, or not most likely, will be trained on. Do we get that? Question. Okay, you didn't get that? Okay, so when we talk about features, features are the characteristic descriptors of that event. We're talking about you getting late to work or the times you got to work, let's say work. And we said, if we are describing the times you got to work, what are the questions we will ask? What are the things we use to describe that event? Maybe you ate before you left home. Did you take a bike or a bus? That's yes or no. Did you, what else? Did you wake up early? All these characteristics or all these features for that event, they can be like columns in our structured data set. And they are the things we'll actually use to find the patterns. That's where we'll find the pattern, right? Yeah, so no, those are the independent variables. So whether you got to work early or not will be the dependent variable. Yes.
I think one for often like the variable right now. We found that we're going to get for.
Yes, those are, I mean, that's it, right? That's the data available to us. Okay. Is it clear?
Yes.
Great. Let me people online. Google Classroom is asking for class code. Please use the link sent to you in the email. All you have to do is check your email. Okay. All right. So let's go. Then the labels of the targets. Now, the labels and the targets are the dependent variable. They are whether is the yes or no, whether you go to work early or not. That is what the features are predicting. Is the final outcome. Is the result. Remember we said machine learning will take your data and the results and produce some set of rules from the first class. Do you remember that? So your labels are the results. They are the results we combine with the data. Okay? So it could be a label or it could be target, or sometimes we call it, when the authors will call it label, call it target. Right? Okay, so this is what the machine learning algorithm is trying to predict. The features are what the machine learning algorithm will train on to learn the patterns. And the label or the target is what it is trying to predict. People following online. So is it clear now? So the person said it wasn't clear. So please confirm it's now clear. No. Okay, I'll go over features and labels again. The features of a data set or of a machine learning problem are the, we call them, I'm trying to maybe speak to statistics now. I don't have other explanations, but they are the independent variables. That is what the actual machine learning algorithm will train on. They are the features like whether you woke up early, you took a bus or a bike. They are the features that whether you ate that morning. They are the things that make up, they are the actual different kinds of things that make up the events that we can record. We could make for as many possible features, right? And what's our target? What's our goal? To know whether you got to work late or not. So we could have another, think of them like columns in your table. And we have a last column that says got to work late or not, or maybe time at work. And if the time at work is beyond 9, we'll say it was late. If it's before 9, we'll say it was early. So the time you got to work is the target or the label, is what we are trying to predict. It could be anything actually, but for this example, it is what we are trying to predict, which is the time you got to work. Yeah, so that's exactly. So that's where we are going now. Let's take a look at this to explain further. The data we're using to train is a set of pictures, as you can see on the screen. We have pictures of a bicycle, of a yacht, of a car, of a plane. And we now say that, okay, the feature vectors are the numerical representation of these images. And you'll find out when maybe by next week when we do something on this, that each pixel of the image will be converted to like a number and will have its own numerical representation. If you've played around with pictures before on your PC, you see that you can actually convert those pictures to one document that will be like just numbers and funny things. If you try to open a picture with the wrong software before, I don't know if I've tried that before, you will see some funny looking things. Those things can actually be translated to numbers, and we can easily do that in Python. So these are the trained data is that data set, the features, the bicycle, the yacht, whatever. And the label is what it is, what we are trying to predict. This is the problem we are trying to predict, what type of object is in the image. So the label for a bicycle will be bicycle, right? The label for a yacht is going to be, okay, it's a boat here, it's a boat. And for a car, it's a car, for a plane, it's a plane. So the algorithm will learn the patterns in this and try to see what makes a bicycle a bicycle. In something like convolutional neural network, we have all things we call feature maps like kernels that will, convolve around the image, and each one is trying to find a particular kind of feature in that image. Okay, and the algorithm is looking for those patterns. And as we keep saying patterns, but it's all just advanced statistics and numbers, really, because it's going to find those patterns as a mapping of numbers for images. It's really beautiful. And then it's going to make its inference. So a new image comes in. Look at the test data. This black car comes in now. We know it's a car. The computer does not know, or maybe we don't even know. Then we ask the computer, from the patterns you have learned of what these past images look like, from the features we gave you, right? From those pictures, from the features we're able to get, is this showing this test data? Is it a car? What is it? And then it will infer and it will output whether it's a car or not, whether it's a dog or not. Do we get that? Is it not clear? Good question. So she's asking about the labels, and that's where we get to types of learning. Because in real life, for example, have you ever, if you saw some of the videos we played earlier or some of the use cases we shared with us, we hear them talk about things like thousands of data points, 1 million data points. And you're like, who is labeling the 1 million data points? Because if we need to label all the images for the computer to know what it is, so we tell the computer this is the picture of a dog, and we tell the computer this is a dog with the label. If we need to label all those images, who is going to label the 2 billion data points that Google uses for language? Who? So sometimes these things are labeled and sometimes they are not labeled. And that's why we have different kinds of machine learning. We have the supervised learning, which is what we have been discussing all along. It's a kind of machine learning where the data will include the desired output, that is the label. So you supply the images of the dog, you supply the images of the cat, and then you also supply the labels, that is the names. So every image of a dog will have a label that says this is a dog. And every image of a cat will have a label that says this is a cat. Every image of a car will have a label that says this is a car. Right? Cool? Nice. Then a good example of this is also the email, spam and not spam. So for every email that comes in, if we were training a machine learning algorithm on that, we'll have a record of emails. And then we'll have whether it was a spam or not. So we'll have that two other columns, spam, ham. So we have spam, yes, yes, no, no, no. Ham, yes, no. Of course, the opposite of it can be spam and ham at the same time. Right? So we have that. Now, the labels, that is supervised learning problem, because every data point has a label. So it's easy to train. We just say, computer, this is it, and this is the answer. Learn the pattern that maps this to this. It's the most popular, it's the most intuitive, it's the most common. Why? It's easy to measure and control. But then it's not every time we have the labels for our data sets. It's not every time, especially for data points that are not frequently occurring. Things like earthquakes and tornadoes, they don't happen every day. And we might not even be able to label all the data points. For example, also things like, maybe you even have an image of so many students and we don't even know their names. Or an image of so many fruits. It's easier for fruits because each fruit is almost so distinct, right? In appearance. So you have so many images of fruits and we want to know which is which. That is where unsupervised learning comes in. And it's a kind of machine learning algorithm where the training does not require desired inputs. And we'll see some examples. It will tell you that, okay, nice, give me your data. You don't need to tell me the labels. I'll try to figure it out on my own. Isn't that nice? Then there's semi-supervised, where the training data actually has a few desired outputs, that is a few labels, and most it does not have for their labels. So it tries to learn from the few it has to generalize for those it doesn't have. All right, we'll look at the examples down below. I'm still going to explain more. And then there's the reinforcement learning, which is the body area now in AI, where the idea is the model is trying to optimize a reward or a punishment. It's trying to find the best method to solve a problem by optimizing rewards or punishment. So if it takes a step, for example, things like self-driving cars especially, they're trying to find the shortest distance to get there. So for every additional second it takes, maybe there's a kind of punishment. And it's not beating the car or something, or removing the tires. It's that there is a metric it is tracking that is reducing. Or if it's trying to maximize a metric. Is that clear? A penalty, exactly. So if, for example, maybe it's trying to minimize the time it will take for it to get to the door. So for every additional second, that means it's taking more time and it wants to take less time. So the model will keep trying different ways and directions until it finds the shortest time. The time that will give the shortest or the least amount of penalty, or if it is to maximize the in the other hand. Okay? And this is just an oversimplification. Reinforcement learning can be applied to so many things, from gene discovery, protein, what's it now? Protein building, the AlphaFold, right? I think it was DeepMind that they had the AI model that did that, to things like resource allocation in maybe game theory, right? How many of you are part of the DSM computational game theory? Anybody here part of that class? Okay, no. So game theory or computational game theory, where you're trying to maybe optimize some sort of game. And when we say game, so it's not the video game, but that an outcome where people have options and each option impairs upon the other person's option. For example, if we had 30 suits to share in this class, if I took 2, you're not left with 30 suits. Unless you want to fight me for my 2, you're left with 28. So how can we optimally share that amongst how many of us are here who are more than this? And if for every option something else is happening. Okay? All right. So let's go on. Okay. So supervised learning. So here is another example of supervised learning where the trained data, right? There's a raw data, they are labeled. Okay, the algorithm takes the raw data that is labeled, learns the patterns, and gives some output. In supervised learning, the idea is both inputs and outputs are provided. A very good example is a classification problem, which we have just seen. You are trying to classify. Classification is between discrete, that is, you know the number of possible outputs. It's either a cat or a dog. It can't be a man. It can't be a cat dog. It can't be a cat. It can't be a dog. Is it a cat or a dog? There is a discrete amount of outputs, so it can be classified. So it's either you went to school or you did not go to school that day. There's nothing like you went not, or there's no other, there's no other outcome. It's either you are here or you are not here. Right? Good. So some types of classification models are logistic regression, decision trees, random forest. And it's wanted to note that, yeah, exactly, if a patient has cancer or not, if an employee will stay or not, what we call attrition, right? There are well-developed models that actually predict that companies, very big companies use to, when someone comes in the HR, because there's so many, there's so like, how do you track each person? So they know, okay, it's like most likely to stay, right? And when you are submitting your CVs for jobs, there are all these models now. Oh, someone says like we online can be here and not actually here. Please be here, okay? Please, as much as possible, please be here. Someone online saying you can be here and not here. Talking about attention there. Okay, can you get this to picture notebook? So the lab part, I would want to share the lab part with us as a collab so that we can all use it. Is that fine? Would we like that? It's really short. Everybody who can type it out, but we'll still share it just so it's easier for us. Okay, so classification models, we mentioned logistic regression, decision trees, and random forest. So for regression, which we'll be looking at one of them today, we make this so we can see properly. We have the linear regression and the non-linear regression. So usually for the logistic regression, the linear one is easily separable. They are clear and they are distinct with a linear relationship between them. That is, as one goes up, one is going down. They are so separable. But it's not every time we can just have a straight line. Sometimes the data points are so interwoven that, in fact, in a two-dimensional plane, you might not be able to separate them. From next week, when we do slightly more advanced things, I'll try to show us with edge impulse how we can actually cluster data on maybe 3 dimensions and see that in 2 dimensions like this, they might look, oh, there's no difference. But when you can turn it in a 3-dimensional plane, you might actually see that, oh, they can be separated like this. So there's a lot to machine learning and to artificial intelligence. And here's where we are actually going to the regression, linear regression. Now, unlike classification or unlike logistic regression, unlike classification where you have discrete outcomes, you have a discrete, a quantifiable amount of possible outcomes, either this or that or that or that. Even if it's 10, you know the outcome is one of these 10. It's a discrete variable. But for regression, on the other hand, it's a continuous variable. That is, it's a variable that has a range, but it does not have exact, no, I was going to say discrete again, but it does not have discrete values. What do we mean? Things like amounts, things like how much rain fell. You can say, okay, there's usually the rain will fall, the rainfall for March is probably between 0, of course, if rain does not fall, and maybe 5 centimeters. Maybe more than 5. Let's say 50 centimeters. No. Yeah, 50 centimeters. No. Let's say 30 centimeters. That's still kind of safe. It's not, I don't think that's flood level yet. Okay, so between 0 and 30 centimeters. Now, it can be anywhere between 0 and 30. It can be 0.1. Do you get? It can be 0.0001. So it's a continuous variable. It has a range, but it doesn't have discrete values. And it might not even have a range. For example, people's weight. Yes, we can say there's some range of the acceptable or maybe human weight, but we really can't say this is the range. We can now do some maybe statistics and say that within this locality, this area, but really we can't say things like how much time it takes. Maybe even the what we have. That's why we have things like average human life, because we can't say that this is the beginning and this is the end. That is so definite. Okay, is that there? When we talk about regression, we're talking about continuous variables. I'm trying to see if people online have any questions. Yes, continuous variable like weight. Example. Someone even already gave the example. So we have continuous variables for regression. Things like prices of houses, prices of cars. It's not yes. It's not a yes or no question, right? It's an exact value. So we can't classify it into because how many 4,000 will you find, or 4,324? So if we call them continuous variables. I hope it's clear. I'm not sure it's clear because I'm looking at glazed faces. Should I explain that again? Yes. All right, let's go over it again. When we talk about regression, regression is a type of model that the variable, like I said, is continuous. Unlike classification variables, where the variables are discrete, it's either yes or no, 1 or 0, yellow, red, or blue. you can count, and here's it, you can count the number of outcomes for a discrete variable. But for a continuous variable, you cannot count the number of possible outcomes. Because it can just have, you cannot say it's between 0 and 100, but what if it's 0.00001, 0.5478, 1.992, 30.24, 30, 30.1, 31, 31.0002. Do you get? It's almost infinite. So it's a continuous variable. We can only define a range. We cannot discretize it. We can't say that, okay, it is, we can't say that, okay, these are the possible outcomes. For a classification task, you already know it's either yes or no. It's either a car, a dog, or a sheep, right? So we can count the number of outcomes, but for a continuous variable, you cannot count. For example, if I say predict the, like we'll see today, we'll try to predict some kind of money. If we try to, you can't say, and we'll see from the examples we'll get that we can't say, it's going to be $30, it's going to be 30 naira. We really can't say, because we can only say it to be between 0 and 1,000. Does that explain it? Nice. I'm glad we are exactly infinite summation. Exactly. Discrete variable again. Nice. People online. Does that mean regression models can only be specified using discrete variables since continuous variables are unpredictable? So no. Yeah, I like this uncountably finite. So regression models can be used for, exactly. Regression models are now used for these continuous variables, while classification models are used for discrete variables. So we have different kinds of models that we can use for each of them. Okay? All right. So unsupervised learning, like we said, it takes the raw. Yes, question, go on. Yes. We have a range, right? Okay, so I'll put the question back to you. So she's asking if we are working with I'm saying for people following online so they can, excuse me, hear the question. If you are working within a range, for example, houses in an area, although it's a continuous variable, you know it's within a range. So my question is, how do you know how many possible outcomes can you have for the price of a house in that locality? So this is how if I'm going to give a one-shot law for that, I'll tell you, if you can find the number of possible outcomes, you can actually get an exact number. It's a discrete variable. But if you can't, for example, houses, you can't say there are 100 possible prices. What if the house is 1 million and maybe 34,000? You can't tell. I don't know if you get it. We have a range. We know it's within maybe 1 million. Regression models are for exactly. We'll see the example, but I want to, if you can get the concept, it's going to make it really. You want to give an example or you want a question? Please go ahead.
Know exactly the specific amount. Just like in this area now, they're like, so like 2 million, 5 million,
yeah,
20 million, 5 million.
Exactly.
I don't know the specific amount. That's when continuous.
But if it's discrete, on the other hand, you know that the price is either 1,000 or 2,000 or 3,000. You beforehand, you know what it can be. Okay, you know that it's either this or this, not a range. Okay, if we are going to talk about things like summations and integrals, when you find out that maybe you have a range and you can begin to sum and take infinite sums of something, but really to bring it down or to bring it home to us, when we talk about the discrete values, and we'll see the example, like the example when we get like practical, you see that we know the tips. Okay, this person gave this amount, person gives this amount, but there's no pattern to there's no exact. One person can, what if I choose to give 3.3 naira? You can't give it in cash, but transfer. And I have friends that they like to just like do those kind of things. I don't. Someone has already done it to maybe as a joke or something. Send you money and add to one couple, right? Because the transfer thing allows it, so it's possible, right? So it's possible. Okay, let me see anybody online trying to say something. Please don't be confused. There's linear regression. Yeah, exactly. Linear regression. So linear regression, which is what we'll cover today, will take continuous variables. Things like prices, things like what else? So let's give examples to show that we're on the same page. Please, if you're online, drop examples of continuous variables that we can use linear regression for. So I want to give 10 examples. People online, 10 examples. There's also logistics. Yes, we mentioned that. That's Falali. Thank you. Okay, so let's give examples. Yes?
This is an example.
Just give you examples.
It's an example and explanation at the same time.
Okay, let's have it.
So for her,
Okay.
there's this idea of the law of one price. It's a finance and investment idea.
Okay.
It's like if the value of
I think we need a microphone. Hello. Okay.
Oh, okay. So there's this idea in finance and the investment. It's like the idea of is a law of one price. So it's like if Google stock sells for 100 naira, then in Nigeria it sells for 100 naira, all over the world it sells for 100 naira. It's impossible for it to sell for another price. So if you buy it in the United States for 100 naira, there's no way that you try to sell it to another country for more or less than 100 naira. That's different from the idea of this continuous variables. We can't know one specific price of how much houses cost in a specific area. It's various prices. Do you follow? Is this understandable? Okay.
Thank you. Another example? What's the other example? So let me read out some of the examples we have already that people have shared following online. We have weight, height, right? Age, area of the place, area no. Price, yes. Time, temperature, yes. Speed of a car, stock prices, yes. Medical diagnosis. So medical diagnosis can be discrete. For example, if I'm predicting a tumor is benign or malignant, right? That's discrete. Either benign or malignant. But if we are predicting the radius of the tumor from maybe for an amount of maybe an hormone or something found inside the tumor, that's now continuous. We are trying to find maybe and the radius will be anything. Please, or microphone. Let's look at another one. Frequency of events, depending, that might not be continuous. Height, continuous, yes. Years, continuous, yes. Length, yes. If you're measuring something, yes. Size, volume, month. So month is not continuous because we only have 12 months. We know already that month is either January, February, March, April. You can't have January 0.2 or like you can't have, for example, days of the month of January. It's not continuous. You cannot have January 32. You can't have that. So you know it's one of 31 days. I think 31, right? Correct. So weather forecast, exactly, continuous. Depending on the weather forecast, if I'm forecasting whether it's rain or not, that is either a rain or a rain. But if I'm forecasting the amount of rain, it's continuous. Are you on the same page? Nice. A fundamental in statistics is really important. Yes, it is super important, Edwin. Thank you for that. So, and that's why there'll be resources on that shared already. Age. Yeah, age is continuous, yes. Number of cars in Nigeria, that is continuous. Number of years, number of months of the year, yes. Car prices, yes. Volume, fuel prices, yes. Number of clothes in the house, yes. So age is not, so age is continuous as well. Food sizes, yes. Distance, speed, probability of an event is discrete. So you will see, I might be able to show you that it's actually constant because we are predicting. You'll see that in, when we talk about. But also depending on the kind of probability, it can be discrete, yes. So time spent online, airtime usage. Yeah, time spent online, yes, that's continuous. Airtime usage, yes. Age is continuous because there's no you can't discretize it. Okay, you can't discretize it. What if I'm a medical marvel and I live to be 1,000 years old? What if I said what if I'm a medical marvel? What if, right? So there's no limit for an age count. Please let me give you an example.
So
a good example of a continuous variable is any variable that varies with time.
Exactly.
So the number of unemployment over time, the number of COVID-19 cases over time, unlike discrete variable where you have a defined set, it can either be 1 or 2.
Thank you. Thank you so much for that. I like how that puts it, that any variable that can change over time is continuous, right? And I think that was going to settle it, that any variable that can change over time, and that's why I don't want to, as I mentioned, there are things that you can find the y, the x for. You can begin to differentiate. Of course, you can differentiate of discrete variables too, but that anything that changes over time, over this time, this can actually change, right? For example, even if, like I mentioned, the months of the year, even if we have year what now, unless there is a new calendar used, we're only going to have 12 months. But for a discrete, you know that it is simply that. Okay. So examples of discrete variables, I already mentioned, maybe colors, yes or no, true or false. What else? We mentioned quite a number already. Benign or not, yes or no. We mentioned quite a number. Yes, male and female. Is it a table or a chair? Anything that can be categorized. Exactly. Anything that can be categorized. Anything that you can categorize. And you can also make continuous variables. You can turn them into discrete variables, Maybe you have your range, and then now, because we've worked on problems before where you try to, and I might give you some tips. Maybe when we get to AI innovation and you're doing your hackathon, you can try your feature engineering, and we get to try different things out. That, okay, we have this list of prices. We now do price 1, price 2, price 3, and we say if it falls within this range, put it in this price. Falls within this range, put it, let it be price 2, falls within this other range, price 3. So we discretize something that was continuous to just 3 classes. Okay, so we can categorize. Yes, of course. So for people, already that all the content in this classroom will be shared on the classroom once we are done. Okay, so let's look at unsupervised learning. Exactly. Nice. We have a lot of amazing people on the call. All right, so clustering. Clustering is super important. Let me talk more on unsupervised learning here. We said that we do not know the outcome variable. Okay? What we are looking for in the data set is the relationship between each data point. We don't know whether it's male or female, whether it's yes or no. We don't know what really is, whether it's this price or not. We just have these data sets. But we are trying to find the relationships. So usually there are about 2 types. They are actually like more, but generally clustering and association. Have you ever had an association rule mining, those kind of things? No? Okay. So clustering is an important concept, okay? And the idea is we have an unstructured set of data. We have customers. For example, we could say we have, anyway, a good example. When everyone entered this class, and we were all just seated, right? We were all students. But once I asked the question, how many of us are using Google Colab? And half of the class, almost everybody on this side said yes to Colab. We now have an information that a cluster. And what does the cluster have in common? So if we're going to label this cluster, we can label them Colab users. And this cluster will just label them Jupyter users. It's the same way Amazon tells you that users who bought this also bought. So they've clustered you with some users. They notice that you click this thing, okay, let's look at all the people that click this thing. What else did they click? So if you are looking at, if someone does got a house, most likely you're looking for furniture, right? So you see people that are buying furniture, you'll be recommending more house things. So the idea of clustering is we want to find a pattern or a structure to categorize set of data. There are different types. Now look at this. And one of the most popular clustering algorithms is the k-means clustering. It's like the most popular, right? Anyway, so when we talk about k-means, and on the left side is the before, and on the right side is the after, exact same data. I like showing this with scatter plots, where before we will not use the images or we will not color the labels, but after you color the labels, even without drawing a circle around it, by yourself, you can begin to see how things that belong to one side are more towards the edge of the graph, towards the left of the graph, or down. So you can already see the after k-means, and it's not as if the Do you know that on the left and on the right is the exact same image? It's the exact same image. The only difference is what it has now clustered them, categorized them. Okay, usually in real life, when you do this, it won't be this definite that there's no all the blues on one side, all the green. That's a miracle, trust me, right? Or maybe there's very well mathematically described relationship between each of the clusters. All right, and association, right? When we talk about association rules allow you to establish associations exactly like set theory. Allow you to establish associations against data objects in large databases. So we have things like relationships between, we want to know who has the most communications via email, maybe in an organization, maybe here. We can have a record of all the emails that go into the organization, and then for every time somebody sends an email to you, a line between you and the person gets thicker. And by the time we do that for all the emails that go on in an organization, you begin to see some very defined lines, right? And we can say, oh, there's a strong relationship between this and this, right? There are a lot of notebooks you can find online that they do that for a lot of books, Harry Potter books, and you begin to see the most popular person in the book. And funny enough, you'll be surprised sometimes it's not even the main character. The name that comes up often, all those kind of things. It's like the same thing you do a lot for transport. Once you look at the most heavily plied roads, we can do the same thing. For every car that passes the road, let us assign some level of thickness to the line. And by also number, right? And by the time you are done, a relationship is set up. Okay? All right. So other examples, so group of cancer patients grouped by their gene expression measurements, group of shoppers, right? We mentioned this based on their browsing and purchasing histories, movie groups by ratings given by a movie user. So your recommendation engines, your YouTube recommendations, Netflix recommendations run on things like this. So because you watch, you like to watch, what are those things now? Top 10 movies, upcoming movies, you keep getting things like that. Because other people like you are watching things like that. And for example, is the way, if you are a very maybe YouTube person and you see someone, you can already tell what someone likes when you see their YouTube or their Netflix, right? Because those things will just keep coming up and you keep recommending them to you. Because other people like you are watching them and say, hey, recommended for you. We think you like this. This movie will be nice for you. Just because you've seen that you like this, someone else like this. You both like the same, the most likely you will like it. Okay? So let's take a look at the machine learning process before we go into the lab session, where we'll try our hands on a what's it called now? Linear regression problem. Okay. So exactly, and this is a very interesting one. This person gave an example on Coursera, like taking courses on Coursera. How many of us, maybe you take courses on Coursera, you will see that by the time I recommend courses to you, they will almost be perfect. And I use that a lot, like I'm like, thank you, because other people, maybe other students in your look, and that's one of the things that Google uses a lot for your search. Have you noticed maybe something happens in the country, a very popular thing? By the time you type the first 3 letters into Google, it's already popping out. Because Google will cluster by location as well. So if 100 people in your locality and Twitter as well are already searching that thing, by the time you also search it, the end user is the most likely that's what you're looking for. And it's more advanced than that, but this is simplifying it. Okay? Nice. Let's take a look at the machine learning process. When we talk about the machine learning process, we are talking about a continuous process. I want this to be all visible. Okay, nice. Yeah, they are both. It's because they are both. So that is to answer most Alan's question about clustering and association. They seem the same because they are both. They are associative algorithms that work with unstructured data. So because they are both working with groups and clusters, they will seem, yeah, Twitter trends, exactly. And when people are using VPNs, you see how your Twitter trends change to the trends in the countries you are visiting, right? It's the same thing. So let's take a look at the machine learning process. I'm going to go over this. We'll share resources on this as well, but it's really important to understand that it's a continuous process and many things involved right? We'll go over them and in detail as much as possible, but there's so much involved in a real machine learning problem. As a matter of fact, one of the most things I hear from people is, I've been doing competition, but getting into a real company, you find out that there's more than just model.predict. Today we don't do model.predict, but there's so much more. I'm sure Oria can tell us a few things about that. There's so much more. Okay, so let's take a look at it. The first step usually is data collection or getting access to the data. So what data exists? We begin to ask questions like, okay, I want to develop a machine learning solution. I want to work on a machine learning project. What data exists to solve this problem? If I'm going to solve the problem of to know whether I will make it to work early or not, I cannot be using data of things like what movie is highest on the box office. What does that have to do with me getting to work early? You see, there's zero. And because something is correlated doesn't mean it causes it. There's a law in statistics that correlation is not causation. A very good example is this. I don't remember the exact name. It's a real life thing. Talking about McDonald's and maybe not going to war and things like no two countries in McDonald's or something have ever gone to one. I remember it's just very funny because they are totally unrelated, but they are also correlated. And it's just to say that, for example, if the fact that I'm trying to go for two totally unrelated things that are just correlated. That is, every time this happens, this is happening. But it doesn't mean this is actually causing it. Is it clear? All right. So we said what data exists. Where can you get it? Yes. So where can you get the data? Is it publicly available? Do you have to collect the data yourself? Do you have to? Is it structured or unstructured? So is it already existing in a table or you have to begin to wrangle it yourself? So when you collect your data, unlike the data we use today, usually data is not always ready to go. It's dirty, it's messy. Somebody was filling the form, the person thought it was a joke and filled the rubbish. No, I see it a lot. I know what I'm telling you. You people filled forms to attend this class now. Some people, and you just look at them and you see a name and like, this is not a name. You know what? So, and you need to find a way to make sure that doesn't affect your data and your work. So you need to clean the data, you need to prepare the data. So we do things like exploratory data analysis to see trends in the data, things that are happening with data. We'll do some of that today. Data preprocessing, getting the data ready for your exact use. And then data splitting, okay? We want to split into train and into test or what else. And next we finally, and you can see that training your model is only out of 1, 2, 3, 4, 5, 6. It's only how many, one step. The most important thing, you feel is the most important thing, but it's not. As a matter of fact, people will tell you things like data preparation is machine learning is 90% data preparation, 20%, or different percentage, but the idea is that there is more of data preparation that goes in than actual model building. So then you train your model, you choose an algorithm based on your problem. So I will not use a classification algorithm for a regression problem. So a problem starts. My model is giving me wrong output. It's a classification problem. You're using linear regression. It's one way. You should use logistic regression or some other, if it's a regression problem, you should use some other regression algorithm. Okay, so usually the first thing you want to do is, what type of problem am I faced with? Analysis, evaluation. Is my model doing well? Feature importance. How important are the features? Maybe there's some features that I put there I don't need. For example, if I try to predict how people would donate money, do we need the names of the people? No. If someone's name is Scholar, does that mean the person will donate more money? No, it's totally. But for example, this is a good example. If all the callers on your list are donating a lot of money, does that mean that if somebody's name is Scholar, the person will donate a lot of money? No. It's just a coincidence. Right? Okay. So let's see what else. Training and inference course, yes, and what look at works example cases. And you can see that the process feeds into one another. So if we see that there's a problem with examples, or people that say things like Femi, anyone with Femi is going to be a heartbreaker. The fact that Femi broke your heart does not mean all Femis are heartbreakers, right? Like, I saw one of my people on Twitter that was implying a certain thread because I know it's things, and right now, people say, can they be like, Emeka, why? It doesn't mean something Emeka did it. Okay, so it's just totally unrelated. Okay, yes, the correlation is there, but it doesn't mean that all Femis are bad. Please, is there any Femi in this class? You're a good person, okay? All right. If you're actually a good person. Okay, then you serve your model. Okay, you want to put your model in production, people want to use it. People are not going to use the model you built on your laptop. We are not going to ship your Jupyter notebook to the customer. We are not going to send your Jupyter notebook to the customer to be running it. Right? It has to be served. Maybe in an application on your phone. Google Lens is a set of codes. I know people wrote the codes at Google, but are you running code on your phone to use Google Lens? It's been served as an application with a UI, user interface, a graphical user interface that you can interact with. And anyone can use, even if you don't have coding experience. And that's one thing we have to, we'll find time to actually step beyond that. As we are building things, a lot of people are building things, but how to deploy them. And one of the simplest you can even use is Streamlit. It's Python, just you can build an app and you can serve your model. Okay. And then, okay, do we need to retrain the model? Are the old predictions now obsolete? Are they still valid? As the data shifted, data shifts, as the trend changed. For example, people's buying trend changes with seasons. If you use a data that only happens from January to February, January to mid-year, your model will be good for mid-year. But once you get to November, why is my model prediction wrong? The buying trend has changed. Awesome. So this is a summary of everything we've said, that your data must be pre-processed. You have to do your learning and error analysis. So this is about it. This is the summary. All you're doing is you're pre-processing your data, normalizing, maybe dimension reduction, whatever it's going to be. There's learning, supervised learning, unsupervised learning, reinforcement learning, some learning. Everything is learning. And there's error analysis, that is precision. Is it we call F1 score, IMSC, MSC? We're going to look at that. That's mean square error and all that, overfitting, underfitting. Because, and really important is, if your model just memorizes the data set, we say it as overfit. And what will happen is you'll be getting 100% accuracy on your data set. Every time you predict, you'll be like, my model is so accurate. My model is doing well. My friend, a lot of experiences on that. And you're like, but by the time you predict a foreign data point that is not your data set, the model will begin to scratch, like, because it only memorized the data, it did not learn the pattern in the data. So any new data point, and it's going to crumble. And also, your model can be underfit. It did not learn the patterns well enough. Sometimes it'll be correct, but most times it's going to be wrong. So we share these references so that you can all go through them. Now, let's try to do this in Python. We have a real-life problem that we need to solve. And we'll be solving it with linear regression. Now, the quick one on linear regression, usually it's really simple. It's considered one of like the simplest machine learning algorithms because it's easy to interpret. I'm telling you, everybody, I'm almost so sure. I mean, you did mathematics, you've done mathematics up onto maybe secondary school basic level. Let me see your hand. If you don't raise your hand, we'll say you should not come to this class again. You most likely you have done linear regression. If you've ever done y equals to mx plus c here, raise up your hand. You've done linear regression. You've done machine learning. You see, what are you looking for in this class? You've done machine learning already. I'm kidding. So it's a statistical model that examines the linear relationship between two or more variables, the dependent variable and the independent variable. We've established that already, right? A linear relationship means that as one increases, maybe the other one increases or decreases, but everything that happens to one is either directly or indirectly proportional to the other. And the idea is it will find a line of correlation that best fits the data points. That is, that line is going to be like a law. That if you can, at this point, this will be this. You can begin to predict that if this is this, this will be this. And we're going to see the example. So it finds a line of correlation that best fits the data points that can now be used to predict whether dependent or independent for even points that are not in your data set. Let me give you a very good example. You know this thing we did maybe when in secondary school, that we will draw a graph with some points. Then you will elongate the line that joins the points. And then for a point outside there, you now begin to trace it to the y-axis or x-axis, and they will actually find the intercept, find the slope, something like that. That is literally what machine learning will do. But can I ask you, can you do that for 1 million data points? Can you do that for 69,000 data points? You begin to get tired. That's where machine learning comes in. Okay? So this is a very good example. So there's a dependent variable on the y-axis and the independent variable on the x-axis. The data points are when x is this, y is this for each of those points. And then that line of regression is the line that best fits the data points, that creates a rule or a rule of thumb or a law that relates the y to the x. It relates the dependent variable, the independent variable to the dependent variable. That for these values of x, we can begin to say that I will have this value of y. So if I draw x up, let me use an annotator to explain this. Where's the okay, I think that's disabled. I don't think I can annotate. Okay, no problem. So like an elasticity graph of 4 seconds extension, something like that, yes. So for every value, you can begin to say, okay, if x is this last one here, okay, on this line, I draw it up to the line, I can begin to find the value of y. Is that clear? Nice. So mathematically, it's in actual statistics and in machine learning, because there has to be an error value. It's represented as y equals to a0 plus a1x plus e, where e is the error value. But it's the same thing as your where y is your target variable, that is your dependent variable that depends on some features, because the features are independent and then they will determine the y, right? Okay, then a0 is the intercept, a1 is linear regression coefficient, and e is the error. How do you account for outliers? Yes, that's where you come to that, where we said the best fitting line. Some points will be left out. For example, check this out. You see that it's not all the points the line passes through, right? So in real life, and you will see, let me show you. So these are examples of correlation known as strong positive correlation if the graph goes up that way, with positive correlation and that. Now, look, this is a graphical example of what linear regression really is. Now, take a look at this. You will see the way. So, good man, please make sure you study this. I think it's a GIF, right? You can see as the epochs are increasing, the line of best fit is moving and the loss, which is the error, is reducing. So for every time we try to fit the line to the data point, we are trying to minimize the error. And the idea is, you can see the data points, right? These are the blue spots. And the line keeps trying to move to find the best way to relate all of them. You can see that though they are closely knitted together, the line cannot pass through all of them. But it tries to find the best possible one that minimizes the error. And that's the idea of machine learning, to find the best fit with least error. The best fit will be the one with the least error. But usually, when we talk about local maxima, global minima, sometimes, especially when we see a linear relationship, you might think you've gotten the best one, but it's not the best. And that's why things like, next class, we might discuss up to there, things like grid search or random search, trying to help you find the actual best version of that model. Okay? So the line is the prediction and the blue points are the data points. And the whole idea is, how can we find the best possible line relating the data points to your predictions? And we'll see that live in class now. Okay? So examples of linear regression problems: continuous variables, predicting salary from years of experience, determining glucose level from age of patients, predicting salary from years of experience. Okay, I think I mentioned that already. Predicting students' grades from total study time, predicting examination score based on students' test scores. Those kind of things, we can begin to say, okay, we have all this data. How can we now use this to make predictions? Are we cool on linear regression? So if it's a little complex, just keep saying in your head, y equals mx plus c, y equals mx plus c. And don't worry, you'll be fine. So let's see how we can do this in Python. And I'll read out the problem statement and then I'll ask you if we are on the right track. One of our clients is the biggest restaurant in Lagos, Nigeria, Mama T restaurant. I own it. It's my, yeah, it's just one of the subsidiaries and things like that. Yes, many things that we do to just, So The objective, right, of this regression task is to predict the amount of tip, that is the gratuity in Nigerian naira. That is, you know, when people go to restaurants and they eat well or not, they would like to tip maybe the waiter or someone that served them. Hey, thank you for a good service here. Or not, you know. So we want to predict the amount of tip based on certain features that we have. And we want to predict it based on the total bill, that is how much the person paid, the gender, was the person smoking there or not, the day of the week, the time of the day, whether it's lunch or dinner, and the size. Okay? So the label is, or the what we're trying to predict is the tip, the amount of money the person gave the server. Okay? I have a question. Is this a regression task or a classification task? Is it a regression task or a classification? We are trying to find the amount of money that was given to someone. Is it a regression task or a classification task? Huh? So people are not saying anything. Refreshment. I'm serious, I had refreshment. Regression, yes. I'm so glad that many of the people on the chat got that correctly. It's a regression task. It's a regression task. It's a regression task. It's a regression task. Okay? All right, nice. Okay, so for people following, you might not be able to type as fast as I'll be running through this, but I will, because like I said, this part of the notebook will be shared with everybody after this session. It's actually available already on the last year's AI Vision material. Is about 150 pages, so you don't have to go relax, you don't have to go through everything, but this part will be shared with you, okay? So the first thing we have to do is import the libraries we're going to use. We need a lot of support libraries. For people that have finished the Python material we shared, this is not going to be strange. Can I see? Yeah, but it's okay even if you've not finished, we're going to run you through what each of them is doing. So basically, we are importing these libraries to be able to help us do more with less. Instead of us writing out the whole code to import the CSV, it's just actually import OS and read there's a Python code you can use to do that. But with NumPy and with Pandas, we can easily do that and get those into more formats that will suit us. So we're importing NumPy, we're importing Pandas. You can actually import them as anything, but the convention is for NumPy you use NP, for Pandas you use PD. So it's asking why it is regression. It is regression because it's a continuous variable. We are predicting the amount of money given to someone based on some features. Okay. So the data set we are using is the data set I shared earlier. So what you can just do now is make sure you, for ease, because I know many people have path problems. So let's just move that, copy it wherever you downloaded it to, and put it in the folder where your Jupyter notebook is. Collab, easy. Top left, click on the file. If you open content, drag and drop it into your Collab. And just copy, right click, the three dots, copy, and copy path and paste. If I use Collab, let me, oh, I don't have a good, okay, I have a nice, but I can't. Okay, Collab, are we good? Why are you saying no? You are lost, Collab. Okay, if I use Collab, let me see what I can do. Yes, so if we share a Collab notebook, you can copy the entire, but you don't have, no, they don't have the notebook yet. They don't have the Collab yet. So create a new Collab notebook. Okay, let me show. Oh, you've done that. All right. So I want to show you here. So I give me a moment so that I can show for Collab. Yes, you need to import everything before you run the code. Okay? Okay? All right, so this is for people using Collab. Sorry, I don't know where the data, where I put the data that we're using. Okay, I found it. All right, great. All right, so for Collab users, I'm going to share my screen now once I create a new notebook. Just give me a second. Can you share your screen again so we can write it? Yeah, sure. I'm going to share my screen. I'm trying to help Collab. Okay, if you are confused, you probably have not seen previous recordings or checked out the Google Classroom. So I'm going to explain in a bit. Please hold on. Where is it? Okay, here we go. All right, so this is what you should see. Moving on to Pandas Profiling. Yes, you need to install Pandas Profiling. Just hold on a bit. I know you might have issues installing Pandas Profiling. Please just hold on a bit. If you're using Google Colab, you are opening your Colab like this, right? You see this file icon at the bottom. Click it. All right. And it opens up into something that looks like this. All you need to do is drag and drop your the data set into that with this window. That's all. Like this. Drag and drop. It will give you this reminder. Okay. And once you've done that, all you need to do is here, copy the path. You right click or you click on the. No, it's really simple. It's something I can do and you can do. I can do and you can do later. So then you right click. I'm sorry, not right click. You just click on the ellipses, the 3 dots. Okay, you see the options. You copy the path. Once you copy the path, actually the path is always /content/ but for your import. I import pandas as PD. Okay. And then I can say data or whatever is equal to pd.read_CSV. Open your brackets, quotes, and then Control V for just paste what you've copied, the path you've copied. That's all. And once you run this, oh no, it's PD, not MPD. Once you run this, you see that your data is imported, and you can say data.head to confirm that, and you're good. All right, so that's all you need to do for Google Colab. Like I said, it's not a big deal at all. All you need to do is once you're in your Google Colab, you click the file icon, drag and drop your data there, copy the path. Okay, all right, so let's go on. So we're going to import all these. We need all these things, right? Here we're going to import our data as tip. Okay, pd.read_CSV reads the CSV file into Pandas as a Pandas data frame that we'll be manipulating and using for this work. So the head attributes of Pandas, of a Pandas data frame, without declaring anything else. Now you might have an issue with this. Most people will. And as a matter of fact, that's why I had to switch laptops. There was something I had to do here before I could get it installed. I couldn't do in time, is why I had to switch laptops. So if you cannot use, or you don't have this installed, you have to just install it. And what you have to do is pip install. Now, if you are connected to the internet only, you have to download the Pandas Profiling. But if you don't have it, there's no problem. You can just follow. We are only using Pandas Profiling for one thing. Hi, Victor. You just joined, so there's no way you can understand what's happening. So please go to YouTube. You can follow the live video from when we started. Okay. How do you import? It's exactly like this on the screen. A bit taller. All right. So let's go on. As we said, you can always go at this video. If you type this exact same code, you get the exact same results. Okay. Are we on the same page, everyone? If you don't have Pandas Profiling, please leave it out. We are only using it for exploratory data analysis. It has no part in the actual model building. So you are okay if you cannot use it. All right? Matplotlib, of course, you need Matplotlib. Everybody, but the Matplotlib is for plotting. We're going to be plotting a few graphs to visualize what we are doing. And you need the inline so that you can see the graphs you are plotting. I did not mount on Colab. You don't need to mount. Okay, you don't need to mount your Google Drive. You can, but you don't need to, because you have downloaded the data set. So just drag and drop it into your Colab. That's all. Okay, let's go on. I read my data as tip, And with the .head attribute of a pandas data frame, I can display the first 5 rows. So looking at the first 5 rows, I can see that, okay, this is correct. This is what our data set is. We are trying to predict how much tip this from all the other variables. Now, we will run into some problem later, but let's go on. So this is tip.head will give you the top 5 variable, the top 5 rows, the first 5 rows. Okay? How many of us have gotten to tip.head? Anybody? 1 person, 2 people. Nice. Okay, so it's okay if you can't follow along. If you can just follow and watch and review the video, because I understand that writing these codes might be a little bit difficult for some of us. Okay? Sorry. Or would you rather, I'm thinking of how I can help. So I'm thinking I can probably copy this into Colab, copy all of this into Colab and share a Colab file now. But that means if you don't have access to the internet, you probably can't use it. Do you understand? I mean, if you don't have access to the internet, I'm not sure it will even work. Okay, yeah, so this is all I can do, put everything inside one cell. So I'm going to try to copy, share this so that everyone can use and make use of it. All right, so I'm wanting to share this Colab link with you on the classroom. Okay, so I'm going to share this Colab with you all on the classroom now so that you can probably use this after the session. Okay? Is that okay? All right. What? Okay, so if you have access to the internet, once I share this Colab, you can use the Colab, okay, and just copy the codes and use. I'm going to send the Colab to the Google Classroom directly for your access. Okay, so let's give me a second. Okay, great. All right. Okay. So I'm sharing the Colab with you I'm sharing the Colab with everyone now on Google Classroom. So if you're on Google Classroom, you will see it under week 3, Intro to Machine Learning. It's going to be on all the classes. All you need to do if you are not on Google Classroom, yes, I already said that leave Pandas Profiling if you can't get it installed. We are only using it for the exploratory data analysis. So you can still do your model without it. Okay? All right, great. So please check the classroom if you want to download the notebook now. Okay, you can download it on the classroom now. So I'm going to just close this. Okay, you can't even see what I'm doing yet. Sorry. What are you using? What? Seaborn. Seaborn is also for visualization. All right. So people following online, please confirm you can access it now on the classroom. I've shared it to the classroom already. Why? You don't have to. Okay, I am going. All right, so if you don't understand what's going on, you can watch the video from the beginning on YouTube. If you do not follow, you cannot understand what's going on. Okay? You can access the Colab notebook. Great. So all you need to do if you can access the notebook is drag and drop the data set. Okay, I'm going to give about 4 minutes. I'll give about 4 minutes for everyone to get that done. For people that want to follow, I'll give about 4 minutes. I'm going to go over all that again. Okay, if you do not get Pandas Profiling installed, again, yeah, that's why I'm not covering it right here now. I can share resources after because of time, because I know that some people might have path issues. That's why I'm not sure. It will take a while for us to begin to show all the different solutions. So what we will just do is, it's only for the EDA, and the EDA, you will see it here. Okay? So again, if you need this, download the dataset and move it to the same folder where your Jupyter notebook is. If you do that, you don't need to find the path. All you need to do is put tips.cs with the name, and you'll be fine. Unless it's not in the same folder as the Jupyter notebook, which is like which folder, you will not, then you need to be doing C, you have to find the path where it is, and then you put that there. It's a CSV file. It's a CSV file. Yeah, the file downloaded is the CSV file. Let me take a look. So I'm just 2 more minutes. How many of us downloaded the data set? It's a CSV file, right? Yeah. Okay, any issues? Raise your hand. My colleagues. All right, what's the issue? Okay, let's address general issues. Let me also look at what's happening online. For people that have issues online. When you download the data set, please send the link to the data set to the chat. All right, so it's been sent. Okay, great. All right, so download the data set. Again, download the data set. Move the data set to the folder where your Jupyter notebook is. Because different people will have different paths. So we can't give one path to everyone. But one thing we can give is, if your Jupyter notebook or your data set is in the same folder as the Jupyter notebook, all you need to do is tips.csv and you'll be fine. So pd.read_csv, and you can read your data set into the tip file. Okay? Are we good? It's not a Python class, it's an introduction to machine learning. Okay, so I'm not even putting it, we're just importing our data. Okay, but don't worry, I understand that. It might look, oh, it's so hard, I have to type all these, but have no fear, they are not things you need to memorize. The more you use them, the easier they will be to remember. The more you use them, the easier they will be to recall. Okay, can we go on? People online, can we go on? Let me get 1 yes on the chat. Okay, great, let's go on. Tip.read CSV tip.head. All right, so let's find the size of the data set, that is the shape. Yes, you need an ID to use Python to run the technical sessions, which was discussed earlier, last session and this session as well. That's for debug. Okay, so tip.shape and then tip.describe. Okay, now tip.describe, what this does is, now you can store your data set as any name. I mean, you could use maybe something else here. Remember your variable assignment in Python, right? You could literally use anything. But know that whenever you want to call it, you have to keep using that. Okay? Now, describe just gives short statistical analysis of the entire data set. The count, there are 744 rows. The mean of this is 2165. That's 2165. Yes, but what if? So inform, that's why we are not sharing the path. You can't share your own path with someone else. Someone else will have a different path. Do you understand? Okay, so tip.describe. We'll give you these statistics. How many of us have gone to TikTok describe? Oh, nice. Quite a number of people. Nice. Okay. Now, profile report is going to give us the Pandas profiling. And what that just does is it gives a exploratory data analysis summary of the entire data set without having to do it one by one, just this, and we get an entire EDA report. You can see number of variables, number of, trust. I already shared the code on Google Classroom, so please join the Google Classroom so you can access it. Missing cells, no, so there are no missing cells. Usually, there are missing cells in many of the data you actually work with. Missing cells, none. Duplicate rows, just one. Okay. Total size, memory, good, good. So now we have 3 numerical variables. Yes, you might not get the Pandas profiling report if you don't have Pandas profiling installed, but that is fine. You don't need it to build the model. Everything you need to build the model you have if you have Jupyter Notebook with Anaconda installed. That is, you install your Jupyter Notebook from Anaconda. That's what we mentioned earlier. Remember the first class we said we are using Jupyter Notebook from Anaconda because once you install Anaconda, Matplotlib, Scikit, all those things come pre-installed. So no hassles. So there are 7 variables. We have numeric variables, you have categorical variables, and we have Boolean. It's a simple linear regression. It won't take time at all. All right. Are we on the same page, people? Profiling does not come with Anaconda. I didn't say everything that you needed. Okay. So this also shows you the individual variables. One by one, we can begin to look at them. Look at the distribution. Okay, what's it telling us? What can we see? And one of the reasons I like this is because we can already see that total bill has a high correlation with tip. You can see high correlation if you have it in stuff, because most of you don't, but it says this variable has a high correlation with one field, tip. That means this would be a very good predictor or a good feature for predicting the tip because it's a high correlation. Okay? If you come here to tip also, it tells you has a correlation with total bill, of course. All right. So basically, what we can tell from this, we can begin to see, oh, there are 409 nails, 335 nails, and you can actually see more details. Okay? I won't be going into the in-depth of the different things we can learn just by going through this processing. But I want you to know that this is possible. This is quite possible. Yes, it will give you an error only because it is not installed on Colab. So time and other details as well. So please, like I said, leave Pandas profiling alone for now. All right, and we'll share results on how you can install that later. Now, this is what the correlation looks like. The correlation plot. This is what it looks like. Okay, total bill tip size, and there's an issue because we can only have correlations for numerical variables. And this is where something interesting comes in. We can only do regression with features that are numerical variables. But if you remember our data set, we have, where is it? Let me show you. We have non-numerical variables. So what do we do about them? Do we just throw them away? No. So let's see how we can sort that out. Okay. So we'll take a look at some of the relationships with categorical variables. With the gender, we have this. This is a box plot that shows the distribution, and you can see the amount of outliers. Okay, and we can see that, oh, nice. They're well evenly distributed. This is cool. This is a nice box plot that's showing us distribution. Same thing for the tip itself. The distribution is quite okay. You can see that this has quite a number of outliers. And what this tells us is that smokers and non-smokers gave almost the same amount of tip. Because this is a box plot of whether the person was a smoker or not, and the amount of tip given. The same thing for time of day. We're using Seaborn to plot this. Don't worry if maybe if you are doing this on your, you can definitely do this. because Seaborn comes pre-installed with Anaconda, so you'll be fine. The code for it, I'm only doing this because I've shared the code for this already on your collab, on the collab. So you might have, and that's why I said that you might have an issue because you might have to just copy out the code one by one and put it in new cells. Because I pasted everything in one cell in collab for time. Okay? All right, so don't worry, you are fine. The video is there for you. And I want you to know that it don't look like there's something complex, something you know, difficult. Everything you need to resolve, we've already shared. So if you check over, that's Mistura, you can actually, because this is like on YouTube, the video is already there, so you can find solutions to all these things. All right. So people following physically, are we? How many of us are?
What's the X equals to 9?
Yeah. So we are defining. We are telling the Seaborn that okay, I want a box plot. On the x-axis, let it be the smoker column, and on the y-axis, let it be the tip. And take them from the data set that is tip. Okay? All right. So we're not building model, we're just doing some simple analysis here. Yes?
Because it is categorical.
Exactly. Yes. And I need a box plot for others too, but for this, yes. All right. Time as well. We've checked that out. Okay, so I know that where the lunch and dinner times also give roughly the same amount. Okay, so all these are not like, I don't say they're not important, but they don't actually contribute to the model building. They'll just tell us, oh, perhaps we take this out, but in this case, we will be using all of them. Now, this is where you might be more interested. As long as you have the data, please let's go on. Now, we're going to import from Escalant Metrics, so that we can evaluate our model. So we'll know how well our model is actually doing, right? When we have made our predictions. Then we also, for model selection, we import train test split, because we need to split our data set into a train test and a test set. We use the train test to train, and then we are going to test. That is, we are going to evaluate our model on the test set. This is very important so that we do not evaluate our model on the same data we train it with. You know what's going to happen? Who wants to give it a shot? I said we need to have a train test and a test set. Remember we mentioned overfitting and underfitting earlier. And we said it's important that the model does not just memorize the data set. Now, when you're done training your data set, we are going to test it, see how good it is. So what we are doing is we are creating a train test and the test set. We are not testing again on the same data we trained. Why? Because if we test on the same data we trained with, most likely the model has seen the data before. It will be easier for the model to actually give the answer. And you might feel your model is doing very well, but the model is just kind of memorizing the data set. So we split the data into two, train and test. Of course, train will be much more than test, right? So that by the time we are testing the data on data, the model on data it has not seen before. Okay? Because of overfitting, exactly. Yes, thank you. All right, so we're going to run that, and then we split the data into the features and the label. It is important that the label does not stay in the feature side. We have to split the data set. So we call that capital X. You could actually use anything, but some of these things are just conventions. So tip.drop, you open your bracket, we are dropping the tip column. We are removing that column from the X. Why? Because if we have the label, what we are predicting, inside the features itself, inside it, we have X and Y, right? What do you think will happen if the Y is already inside the X? So that's what's going to happen here if we do not remove tip from X. What? Let me give you an example. We are trying to equate X to Y, right? But let's find a way that a set of relations or the pattern between X and Y, right? Now, if part of Y is already inside X and we will now say X equals Y, what have you done? Nothing, exactly. Your model will just be telling you 100% accuracy because Y is already, it's like I say Y is equal to Y. So we have to remove the tip column. So we remove it, and then we are left with just the predictors, the features. And then we take that tip and we put it, only the tip, that is the labels, the target, we put it into y. So we say y equals to tip, we open the square bracket, exactly, and we put tip, okay? All right, so that's what we just did there. Now, just so you see that the tip is gone, you see that this, if we do tip dot head, we still have all this tip is there, but once we change this to x dot head, you see that tip is no longer there. We've dropped it. X is your features. You see here, we put from this whole tip, let me show you, from the tip data set, okay? We took this tip data set, we took everything there, right? We removed tip from it, and then we put those into X, such that X is now all the independent variables. And Y, check it out, Y is what? The dependent variables, which is tip. So X is all your independent variables now, and Y is the dependent variables, like your Y equals mx plus c, and the other equation we saw earlier. All right. Next thing we need to do is for categorical variables. Now, this is just a walkthrough showing you how to implement what we have actually learned in theory in Python. For categorical variables, we need to find a way to convert them to numerical variables. And what we'll do is simple. If we have two categorical variables, everywhere that variable, for example, if we have two categorical variables, we create two new columns. We create one for the yes and one for the no. So everywhere we have yes, we just put 0, and everywhere we have no, everywhere we have yes, we put 1, everywhere we have 2, we put 0. We put 0. That creates two new columns, right? If we have something like Monday, Tuesday, Wednesday, Thursday, Friday, we create 5 new columns. Everywhere there is Monday, that Monday will have 1, the other values will be 0. When it's Tuesday, Tuesday will have 1, the other values will be 0. That's the get dummies format. It's called one-hot encoding. And the idea is, for where that variable is true, it will take a 1, every other variable there will take 0. And so doing, we can convert any categorical variable to a numerical variable of 1s and 0s that our model can actually take. Because if your model won't take text, we can't do analysis, we can't do statistics on text. So we need numbers. So we're going to use what we call one-hot encoding. And the simple way to do that in Python, okay, is x is pd.get_dummies x. And what we are saying is, remember variable assignment? Take what is in x, do the get dummies on it, and get dummies will generate one-hot encoding for every categorical variable. Once the categorical variable, the get dummies function will generate one-hot encoding for them. And if you print it out, you see this. So we have gender, female, gender, male. Where gender is male, you see that the male is 1 and female takes 0. Smoker, no smoker, yes. Where smoker is 1, the other will be 0, and just vice versa. So doing, we've converted all the categorical variables to numerical variables by just saying pd.get_dummies and x. Now we have 15, oops, I didn't run this. Now we have 15 columns, but we still have about 744 rows. Okay, we're getting closer. Next thing we do is we need to split the data into training and test, like we said earlier. So to split them to train and test, we use what we imported earlier. Now all this is just, I think I showed something like this in variable assignment. That I think I did how you can assign multiple things to one variable at the same time, as long as it's outputting something similar. So we are assigning about 4 things to these variables: x train, x test, y train, and y test. And don't be confused, if the formula, this is like a formula, it takes in what it wants. What it wants is declare your x and your y. Our x is our capital X, and this y is capital Y. If I use maybe something else here, that has to come here, okay? And then the test size. So what's the ratio of your train to your test? We said that we need more for training, right? So 20% is okay for testing. So if we have 744, 20% of that will be taken for test, and we'll only learn the patterns from the other 80%. Now, if you want to get the exact same values, exact same records I will get, you need to use the same random state I will use. I use 42. Now, the random state is just the way the data will be shuffled, because once train test split is done, it will kind of shuffle the data. And so if you want it, because it will do it randomly, it will select, there's a way it selects in some order. So if you want to get the same values as everybody else, you use the same random state. Well, as long as the other things are also, maybe your hyperparameters, but we're not talking about that today. And we are ready to make our predictions. Now, this is where our packages really make everything so simple. The entire algorithm we learned earlier, the y equals mx plus c, how it's minimizing the loss, everything is done with one line of code. You import your linear regression model. The next thing is, we call the linear regression model. You don't need to, but sometimes I just like to have it in another variable, call that variable model. And then say model.fit x train and y train. This single line of code is all the training we've been talking about. Like the length, the pattern in the data set, it's done in this line of code. So when I run my train test, I get my x train, my x test, y train, y test. Now, x train is what will train remember we said x is what? The independent variables, y is the dependent variables. X train is the dependent variables we train on. Y train is the dependent variables we train on, because the model needs to be able to know that it is going in the right direction or not. So it learns the patterns in x, looks at the right answer, looks at its answer, how far off am I? It adjusts, runs it again. Then we say model.fit x train, y train. X test is what will test the model on, the features. And y test is the answers for x test. Is it clear? Nice. I'm actually glad that I feel a number of people are actually following there. Okay, so what next do we do? Model is this, model.fit, and then once we've done the model.fit, the model trains, and then we save the predictions when we call model.predict. And we predict on x test, which the model has not seen before. We've split the data set into train and test. Now we have x train and x test. We're going to predict on x test, which the model was not trained on, which is like a new data set to the model. So once we run our predictions, we use this to just print out the first 10 predictions and see what they look like. And it's done. Even if you're using a mobile phone for this exercise, this will do simply, because the linear regression is a very simple model. What? Yes, so these are the predicted tips. Now, I'm going to show you what the actual values are and how far off our predictions were. Then we'll do a metric called the root mean square error, which shows about how far off we were on average. All right, so I created a data frame from the actual values and what we predicted. That's all I did there. And this is it. I call it comparison, and this is it. So the actual value was 436, but we predicted 290. Far off, right? Actual value was 545, we predicted 358. Far off, right? And you can begin to look at it one by one. But look at this one. Actual value 378, predicted 372. So close. And if you look through all these predictions, the actual values and the predictions, you will see some that are very close, you see some that are far off. And a good way you cannot see it and is okay. What's the error? The error is the actual values minus the predictions. And these are the errors for each of them. You can see this one is even 556 off. That's a lot. So we'll use a metric called mean square error. Mean square error is about the total mean of how far off from the real value all our predictions were. And once we run this on y test and the predictions, we get 26,869. It's a lot. But when we need to find the root mean square, which I can put it into perspective about really how far off are we for like each of them. And on average, it's about 163. So it's not too bad, it's not too way off. When you look at the fact that the maximum tip was 1,090 and the minimum tip was 0. And you can begin to gauge yourself about how far off you are if we go to the reports. Now, this is simple. We didn't even do, We didn't do any hyperparameter tuning. We did not optimize this model at all. This is about the baseline model. This is the weakest model we can build. And if we look at the tip, I want to pull up the tip so we can look at a bit of what the numbers look like. So this is the tip. I'll go to toggle details, and then let's look at the extreme values. The minimum 5 values are 0. These are the minimum values, the lowest tips. And the maximum tips are this. And if you look at now, this is where we go with distribution. If you look at the distribution, you will see that all these are outliers. Most of the tips given are between 0 and 800, or let's say 600, thereabouts. And mostly people get between 200 and 400. But by the time we get our predictions, we are off on average for each tip by about 160. So this is a very weak model. It wasn't too accurate, it wasn't too bad, but this model can be better. How can we make this model better? How can we use linear regression even better? We'll learn about hyperparameter tuning and even more features of models, how we can make models better. Number one way we make a model better is find more data. Usually, when you find more data, usually not all the time, right? You might get a better model. Let's try something. Let's reduce the test, add more to train, right? And see the model will increase a bit. I doubt it's going to increase, but let's do 0.1. Yeah, this is a cheat, but let's just see if it will actually help our cause a bit. So we now have 162. Did that increase or decrease? I think it decreased. It reduced a bit. So if we could have more data for the tips, if we could have maybe 10,000 or 5,000 more, this might actually improve again. Okay? So please, I know you have a lot of questions and everyone's like, what just happened? But please, as much as possible, review this video. Okay? That's why we are recording the video. Okay? Review the video, ask questions on Google Classroom. We'll be dedicating more resources to Google Classroom this week to answer your questions. So ask more questions on Google Classroom. Ask the questions we are here to answer. I will be sharing some more resources to also help you. Okay? So we'll see you again next week. But before we go, I have a few important announcements for you. And number one is tomorrow, the learning continues. Tomorrow we are hosting an NVIDIA session. It's a physical event, but it will also be streamed live, like the way we do this class. You can join online or physically. We're going to be hosting a Carlos from NVIDIA. She's coming here and we're going to have a master class on data visualization. So if you're interested in data visualization, you saw all these things that we did. These are visualizations, how we can interpret all these things, how we can begin to look at data visually and understand the data. It's tomorrow. The time is same time as this class, 12 to 2. And speaker is Scikit from NVIDIA. She's the USA Director, Head of Global Developer Relations and Emerging Markets. She's an artificial intelligence and machine learning engineer all the way from NVIDIA. So guys, women in AI, today is your day. We are still celebrating tomorrow. So let's come and learn. I know there's a registration link for everyone in this classroom. We'll also share it on maybe the classroom or via email so that you can register ahead and please join the session. Okay, so I know this is 2:05 and we are closing now. Yeah, sure, it will be on Google Classroom. I'll try to share that. So if we have, I think we can take 1 or 2 questions. I saw your hand up earlier. Question?
There's a place I saw test.something like test.site. I don't know what it is used for.
Yeah. So let me quickly show that. Please turn my off. So this is a test size. Test size is for the size, the ratio of train to test. So we are saying that keep 0.1, which is 10% for testing. If this was 50, keep 50% for testing. Divide this data set by the ratio 0.5 to 0.5. Okay, divide the data set ratio 0.6 to 0.4. keep 0.4 for testing, and keep the other 0.6 for trading. Which is like saying 40%. Usually they use 30% or we use 20%, but really there's no hard and fast rule, but trend should be more than test. Because you want as much data as possible for test. Can you let us know what it takes to get a job with the ML company? Yeah, so anyway, next question. To get a job, you need a project portfolio, what you have done. There are some certifications that certain companies also want, and they can work with frameworks the industry uses. Python, Spark, Azure, AWS, and Hadoop, and all these other things that the different industries use. So for each job description, honestly, it can't be different, but generally, you can work with the tools and you've done amazing things that can be shown in your project portfolio. Like this, someone can take this tip CSV that we just did and make a proper project out of it. For example, what we've done here is really simple. Can someone go and look for linear regression hyperparameters? How can I tune the hyperparameters of this? Maybe find a way to optimize between grid search and random search. Grid search will take a long time. Mechanize random search, find better parameters, improve this model accuracy. And can I serve it as a, okay, you enter the values on your phone and it will tell you how much tip the person is most likely to give. So different things you can do. And as a matter of fact, you have next class will be another project. We'll just review this a little, and most of that project will be more on deep learning on how you can use this. Someone is asking the results. Please just check the video again because this is it, and we showed how that this was our prediction. Okay, so you can just check the video, check the replay. Profile report, the variable used is different from the one defined in the code that was used. Nope, it's the same thing. Profile report will only show what is in the data set. So if it's not in the data set, like it won't be used. So you can see it's the same thing here, and it's the same thing in the data. Maybe the variable name is different. That's other working. So please make sure you check the video. So I think we've taken 8 minutes extra. Apologies for that. But I hope we've. How many of us know more about linear regression today than we knew before? Nice. How many of us can implement linear regression? How many of us can explain it first? Everybody should be able to do that. Nice. But now, how many of us can implement it in Python yet? Okay, I understand that it might be, okay. But of course, there are new codes, you might have to review them. So please check out the collab. But what is going to make this stay for you is the collab that was shared already on Google Classroom. Take the collab side by side, maybe the video recording, and try to walk through it one by one. Each cell, try it yourself. Make sure you try it out. And I'll make sure that the assessment for today's class will be easier for people that actually try it out. We'll find a way to make that work. Okay? Awesome. So thank you all for coming. I look forward to seeing you tomorrow. I'll let see your faces tomorrow at the session if you can make it. Tomorrow's session, okay, now to go over it again with Kate Carlott, data visualization masterclass right here or online 12 to 2. Please be there. Okay, I think that's about it. Okay, so a review link will be sent to you. So please make sure you click on it. If you have a personal project you need help with, please reach out to any of our community channels. You can use the Telegram. We have a lot of people that are always willing to help with that. All right, so cheers everyone. I will share a proper notebook as well. I'll try to put this on a proper notebook so that everyone can access it. Okay, we'll get that today. The recording is already on YouTube. We'll share that as well and other resources to help you. All right.
So I can just see
Sure.